Hey everyone! So, let's talk about AI. In just the last few years, it's exploded from something you'd see in movies to something we're all using, every single day. I mean, think about it. Things like ChatGPT can write poetry, they can code, they can hold conversations that feel, well, shockingly human. But how on earth did we get here? Today, we're going to pull back the curtain on that entire journey.
I mean, it really does feel like magic, right? One minute we're all laughing at chatbots that can't even understand a simple question. And then, blink, and we have AI that's creating brand new art and writing these incredibly complex essays. So what happened? How did that massive leap happen? And why did it happen so fast? Okay, let's dive right in. To really get a handle on where we are now, you have to see the bigger picture. We are living right in the middle of what experts call the third great revolution in artificial intelligence. And this isn't just about making computers faster. This is a totally fundamental shift in what AI is even capable of.
You can kind of break down the whole story of AI into three big acts. It all started with what are called rule-based systems. That's where people, humans, had to sit down and write out every single possible instruction by hand. Then came Act 2. AI started to learn from data, kind of like a student cramming for a test by looking at old examples. And that brings us to where we are today, the third act, generative AI, where the machine goes beyond just analyzing what's already there and starts creating something totally new.
So let's talk about that first massive jump. That moment we gave up on trying to write a rule for every single thing in the universe and instead decided, hey, what if we could just teach the machine how to learn for itself?
The problem with that first wave of AI was actually pretty simple. There were just way too many rules to write. I mean, just try to imagine writing a rule for every single way a person could ask a question, or every possible move in a game of chess. It's literally impossible. The real world is just too complicated, too messy for a simple list of if this, then that statements.
And the solution came from this completely different way of thinking, and it was defined way back in 1959 by a pioneer named Arthur Samuel. He called it machine learning, the ability for a computer to learn without being explicitly programmed. I mean, this idea was a total game changer. Instead of feeding the computer the answers, we would just teach it how to find the answers on its own. That shift in thinking changed everything.
Okay, so how does a machine actually learn? Well, it pretty much boils down to three main flavors. You've got supervised learning, where you're feeding it labeled examples. Then there's unsupervised, where it has to find all the patterns by itself. And finally, reinforcement learning, which is all about trial and error, basically trying to get a reward, like training a dog. Let's just quickly put the two most common types side by side to make it super clear. Think of supervised learning like you're studying with flashcards. You've got the question on the front, and you've got the correct answer on the back. The machine just learns to connect the dots. Now, unsupervised learning, that's more like someone handing you a giant, messy box of old family photos and just saying, sort these. You have to figure out the patterns and groups all on your own. So, machine learning was a huge step for sure. But to get to the kind of AI we have today, it needed a serious boost. It needed to be supercharged. And this is where deep learning crashes the party. And its story is really one of failure, of persistence, and just this perfectly timed collision of different technologies.
You know, the road to get here was not smooth at all. In fact, AI went through these long periods called AI winters, times when all the funding just dried up and progress ground to a halt because the hype was just way ahead of the reality. A really key technique came out in the 80s, but it didn't really work on the hard problems yet, which led to another winter. It wasn't until the mid-2000s that the third boom really truly began.
So what changed? What finally broke the ice? Well, it wasn't just one thing. It was this perfect storm, this trio of ingredients all coming together at exactly the right time. We finally had the right algorithms, we had the insane parallel processing power of GPUs, which, funny enough, were built for video games, and thanks to the internet, we had access to these unbelievably huge mountains of data to train on. That trio was the rocket fuel AI had been waiting for.
All right, so now we've got the raw power. But how in the world do you apply that to maybe the most complicated, nuanced thing humans have ever created? Language. This was the next great puzzle to solve. So here's the thing you absolutely have to understand. Computers don't speak English. They speak math. They get numbers. So the entire challenge of what's called natural language processing, or NLP, is all about finding really clever ways to translate our messy, contextual human language into a structured numerical format that a machine can actually work with. So these early models, they tried to do this by basically squishing the entire meaning of a sentence down into one single chunk of numbers, called a context vector. Now this kind of worked for really short sentences, but for anything long or complex, it was like trying to summarize the entire Lord of the Rings trilogy on a single sticky note. Most of the important information just got lost.
The aha moment, the breakthrough solution, was this mechanism with a really perfect name: attention. Basically, it lets the model look back over the entire input sentence and decide for itself which words are the most important for figuring out the very next word. It's like giving the AI a magical highlighter pen, so it can focus only on what really matters, and that stops all that crucial context from getting lost.
And all of this genius came together in this revolutionary new blueprint called the transformer architecture. It threw out the old, slow, word-by-word way of doing things, and instead it could read whole sentences or even paragraphs all at once, which made it perfect for those powerful GPUs we talked about. It uses this thing called self-attention to figure out how important every single word is to every other word, so it truly gets the context. This right here is the engine behind ChatGPT and basically all modern AI.
So let's recap. We've got the learning methods, we've got the insane computing power, and we have this game-changing architecture. The question is, what happens when you finally put all of that together? What do you get? And here we are. This is what it all leads to. A large language model, an LLM. It's the culmination of this entire incredible journey. It's a massive AI model built on that powerful transformer architecture that's been trained on a huge chunk of the internet, which gives it this almost scary ability to understand, to summarize, to create, and to talk in a way that feels, well, human.
You know, way back in 2015, one of the godfathers of modern AI, Dr. Andrew Ng, said this. He called mastering machine learning a new superpower. And honestly, when you look at what these LLMs can do today, it's pretty hard to argue with them. We have given machines the ability to learn, and in doing so, we've given ourselves a tool with just unbelievable potential.
So, that's the whirlwind tour of how we got here. From these super rigid rules to machines that can actually learn, through all the AI winners and all the breakthroughs, we've landed in this incredibly powerful moment. Which, of course, leaves us with the biggest question of all, right? Now that we actually have this superpower, what comes next? What are we going to choose to build with it?